So I was pulling up the paper so we could start the problems, and I noticed I did something wrong on the last video. When you go back to number 26E, it says how many items should be sold to maximize the revenue. I didn't answer that question. I answered profit, probably because I get busy talking. So let's go back and fix that. So here, I want to first find my pen, see if my pen will work. There it is. All right, so let's go ahead and answer that revenue question that I was supposed to answer, and I got too busy talking that I missed it. So if we look back, we can see that the marginal revenue was 12 minus 0.5x. So if I take that 12 minus 0.5x and set it equal to 0, I get 12 equals 0.5x. If I divide both sides by 0.5, I get x is 24. All right, this first derivative for revenue was 12 minus 0.5x, so the second derivative would be negative 0.5. Again, we have that idea that it's concave down, which makes this a max. So that finishes what I should have done on E the first time. All right, so 27 I've already done. Let's go to 28, where it says find the relative extrema of f of x is a third of x plus 7/2 of x squared minus 18x minus 30. So like everything else, we start with the derivative. I have x squared, I have 7x, I have minus 18. I want to set it equal to 0, so I'm looking for factors of 18 that come out to be 7, so that would be 9 and 2. 9 will be positive, 2 will be negative. That says x is negative 9, that says x is positive 2. Alright, so I'm trying to find out which one's the max, which one's the min. So I need to do something else. So you have a couple of choices of what to do. You can do a chart, or you could take the second derivative, and I do think the second derivative is easier, so that's what I'm going to do for you. So x squared becomes 2x, 7x becomes 7. What I want to do now is I want to take these numbers we just found, the critical numbers of negative 9 and 2, and plug them into the second derivative. So if I do f double prime of negative 9, that's 2 times negative 9 plus 7. That's negative 11. Knowing that it's negative says it's down, that says this is a max. Same thing, if I plug in 2, I get 2 times 2 plus 7. That's 4 plus 7 is positive 11, which is concave up, so that's a min. I do think the best answer is to give me the actual points, so not just give me a coordinate. So I'm going to my calculator and I'm putting in the original function into the y equals. So I have a third of x cubed plus 7/2 of x squared minus 18x plus 30. And then I'm switching over to the table and I put in negative 9. And then I put in positive 2. And because I always think I need to double check myself, I'm just going to make sure that I put in the right thing before I put the answers. So this tells me that negative 9, 172.5 was my max, and 2, negative 49.33 is my min. Let's kind of box that off so you can see it. Maybe take it off of there because now you can't see the next question. Okay. Number 29 says find the inflection points. So let's start with the first derivative. This will be 4x cubed over 12 plus 15x squared over 6 plus 4. We could reduce that to x cubed over 3. The 15 and the 6 have 3 in common, so I have 5x squared over 2, and I still have that 4. Second derivative gives me 3x squared over 3 plus 10x over 2, and then the 4 is gone. This reduces nicely down to x squared plus 5x. So the x squared plus 5x I want to set equal to 0. I see that I can take an x out. So I get x is 0, I get x is negative 5. So just like I did in the last one, once I found the coordinates that I want to plug them back in. So to get actual points and not just numbers. So 0 is easy. If I plug in 0, I get 9. The negative 5, though, I do want to use my calculator to figure that out. So again, I'm going to the y, and I'm telling it x to the 4th plus 5x cubed divided by 6 plus 4x plus 9. And then over at my table, I put in negative 5 to see what I get. So I have to check something real quick. I forgot my divided by 12. All right. So then at my negative 5, it says negative, this is 63.08. 30 says find the intervals where the function is concave up and where it's concave down. So same kind of idea that I'm going to look for my inflection points to start. So I have negative 3x squared minus 24x minus 45 as my first derivative. Second derivative is negative 6x minus 24. So when I set that equal to 0, I have negative 6x minus 24 is 0. Negative 6x is 24. X is negative 4. So on my number line, I put in negative 4, and I make my two intervals. Okay, so I have negative infinity to negative 4, then negative 4 to infinity. I'm going to pick a number in each interval, so say negative 5 and 0, and then I'm going to plug those numbers into negative 6x minus 24. Pay attention to this negative with the 6, sometimes it's easy to mess that up. So negative 5 times negative 6 is 30. 30 minus 24 is positive. 0, when I plug it in, I have 0 minus 24 is negative. So this first interval is concave up, and I'm just going to draw the U for up, and this is concave down because I don't have space. So I'll write it over here. Concave up from negative infinity to negative 4, and then concave down from negative 4 to infinity. (31) says find the absolute extrema on the interval negative 3 to 6. So I'm starting with the first derivative. So x cubed derivative is 3x squared. Minus 3x squared, I get negative 6x. Negative 24x is minus 24, and the 5 goes away. I look at 3, 6, and 24 and see they all have a 3 in common, so I'm going to factor it out. So factoring out the 3, I have x squared minus 2x minus 8. Then I look for factors of 8 that give me 2. So 8 could be split into 4 and 2. It would be x minus 4 and x plus 2. So x is going to be negative 2, x is going to be positive 4. So I look at these two critical numbers, negative 2 and 4, and I notice that they both are within the interval negative 3 to 6, so it says I get to check both of them. So we're going to check those two numbers, the negative 2 and the positive 4. We're also going to check the negative 3 and the positive 6. So if I give you on a closed bound, you have to check all of them. All right, so that's a lot of numbers, so definitely want to use our table. So I'm putting in x cubed minus 3x squared minus 24x plus 5 into my calculator, and then I kind of just always double check to make sure I got everything in there, I didn't hit a button wrong. Alright, now I'm flipping over to my table and putting in negative 2, positive 4, negative 3, and positive 6. Alright, so at negative 2, I see that it gave me 33. At 4, I got negative 75. At negative 3, I got positive 23, and at 6, I got negative 31. Alright, so I look through those numbers and I can see negative 75 is definitely the smallest. This is my absolute min. And then 33 is the largest, so this is my absolute max. Number 32 says a company found that its weekly profit for the sale of X units of a home entertainment system is given by P of X is negative 0.02 X cubed plus 5400X minus 85,000, where X is greater than or equal to 50 and less than or equal to 450. Find the maximum possible weekly profit the firm can make. Alright, so this is just like the last one. It's just an absolute extrema problem. So we're going to start with taking the derivative. So I have negative 0.06 x squared plus 5400, and then the 85,000 goes away. I do have an enclosed interval of 50 to 450. The only big difference I see besides the words between the last one and this one is you only want to know the maximum. We don't want to minimize the profit also, so just the max here. So I'm going to set this derivative equal to 0. So I have negative 0.06 x squared plus 5400 equals 0. I can move the 5400 to the right side, so now it becomes negative 5400. Then I'm going to divide by negative 0.06, which gives me 90,000. When I take the square root, I'm not going to put plus or minus because I can't make negative units, so I'm only going to keep the positive number, which was 300. First thing to do with that 300 is make sure it falls within our interval, which it does. It's between 50 and 450. And then we're going to check those three numbers. So we're going to find P of 50, we're going to find P of 450, and we're going to find P of 300. The order that you do them doesn't matter, it's just make sure you get all three numbers. Right. So once again, I'm going to the calculator and I'm always plugging in the original. So I have negative 0.02 x cubed plus 5400 x, and then minus the 85,000. Right, so the first number I have is 50, which says 182,500. And then I had 450, which said 522,500. And then the last one was 300, which says 995,000. Okay, definitely that's the biggest one. The question was find the maximum possible weekly profit. This is the maximum weekly profit. Sometimes it's really important with a word problem to go back and see what did I ask for. So did I ask for how many items should I make, how much the profit is, what was the price, right? So make sure you go back and read what the question really said. All right. 33 says find the absolute extrema of x plus 1 squared times x minus 3 cubed over the interval negative 2 to 1. So we're starting with the derivative, and there's two things going on here. We have a product rule and a chain rule. So let's start with the product rule. The x plus 1 squared, I'm going to take the derivative of that, which brings the chain rule in. So I have 2 times x plus 1. I keep x minus 3 cubed. Then I go back to the x plus 1 squared. I take the derivative of x minus 3 cubed. I get 3 x minus 3 squared. In both of these, if I took the derivative of x plus 1, it would be 1. X minus 3, the derivative is 1, so I did nothing. My idea is I want to set this equal to 0, so you want to really be checking out what do they have in common. So they both have an x plus 1. Oops, it's not picking up that pen for some reason, so I guess we'll just go back to a color. So they both have an x plus 1. They both have an x minus 3. So as I'm starting to factor this, I'm going to take out an x plus 1, but I only get to take out power 1 because that's the smallest power. And then the x minus 3, I take out a power 2 because that's the smallest power. Okay, so now I look at each term. I still have this 2 here. X plus 1, I've taken that out. X minus 3, I took 2 away, so there's 1 left. Same thing on this side, on this term, the x plus 1 squared, I took 1 x plus 1 away, I have 1 left. I still have the 3, but this x minus 3 squared has been taken care of. So I have x plus 1, I have x minus 3 squared, and then I'm multiplying out, this is 2x minus 6 plus 3x plus 3. So now I have x plus 1, x minus 3 squared, 2x and 3x makes 5x, negative 6 plus 3 is minus 3. Right. So we are setting that equal to 0. That says x equals negative 1, then x minus 3 gives me x is 3, and then 5x minus 3 says 5x is 3, so x is 3 over 5. Okay. So as I'm looking at that, again, the first thing I do is I go back to this negative 2, 1, and I say, are they all in there? So negative 1 is there, 3 is not, so I'm just going to get rid of that one, and 3/5 is there. Okay. So now we want to put all those numbers in and see what it gives me, and I see I don't have a lot of room left. So I'm going to look at f of negative 2, I'm going to look at f of positive 1, I'm going to look at f of negative 1, and I'm going to look at f of 3/5. Okay. So, go back to my calculator, go to the y, put in x plus 1 squared, and then put in x minus 3 squared. I'm sorry, cubed. So I have x plus 1 squared times x minus 3 cubed. I go over to the table, I put in negative 2, and it says negative 125. I put in 1, and it says negative 32. I put in negative 1, it says 0. And then I put in 3/5, and it says negative 35.39. All right, so I see negative, negative, negative. The only one that's not negative is the negative 1, 0. So this is actually my max. Then looking at negative 125, negative 32, and negative 35.39, I can see negative 125. This is my absolute min.